This is Flare Engine, welcome. In this tutorial we'll be looking at components that can save game state, and we'll also look at some other features, but the central theme for this tutorial will be saving. Also, I want to mention that there's still more to cover in the AI series, but I will circle back to the AI once other systems have been covered. There's enough material in the AI videos to get you creating your own stuff, and if you need help with specific mechanics or need to create a node, let me know, I'll help you. I also updated Flare to version 1.4, so please update, as there will be things in this tutorial not available in the previous versions. Okay, let's begin. I duplicated Demo 2 and got rid of some stuff to have a foundation to work with. You can do the same if you want to follow along. The engine implements something called world variables as a generic way to save game data. The health component is part of this class. We'll go to the player and remove these components and start from scratch. Okay, when working with a world variable, the most important thing for saving is giving it a unique name. This name must be unique across the entire game. You can press this button to generate a unique name ID if you don't know what to name it. And of course, we must enable the save option. After that, the game will save the world variable at the end of the scene and will restore its value at the beginning of the scene. You can of course call the save method on any specific variable to save it anytime you want. The value represents the current value of the health variable. Clamp means the health can't go higher than 10 or lower than 0. And we'll give ourselves a recovery time of 1, taking damage at least once per second. Now, we go into play mode and verify that the value is being saved. Player is not reacting to getting hurt, since we haven't set a pushback. Okay, we can see we took damage. We're at a value of 9 now. We exit. We see the value has deserialized to its original value. Let's go back into play mode and we should see this value initialized to 9. Okay, great. Okay, now we'll add a world float. This works exactly the same as a health component. The only real difference is that it can't detect damage. World floats, as with all other world variables, can represent anything you want them to. This world float can be coins, experience, anything that is relevant to your game. In this case, it will represent coins, and of course, there is no limit as to how many you can place on a game object. All of them work independently and can be placed anywhere. This allows for a modular workflow. We name it and enable the save option. And now we're going to work with something called the world HUD. This is used for UIs to display world float information. We create a canvas and configure some settings. We add a panel, rename it, and remove the image. We add a child image. This will be the heart icon. We also add a horizontal layout group to control the spacing and position of the hearts. We duplicate the hearts for a total of 3, and now they're arranged at the top left corner. Finally, we add World Float HUD. There are 3 types. Discrete items will display the value in terms of items. Continuous is used with image fill to set the length of an image according to the value, and numbers will use text to display the value. We select discrete items. We set the sprites. We need an active and empty sprite. And we set the reference to the hearts. You should only set one of these options, and we'll set the reference to the player's health components. We go into the player, we press the delete button to delete any saved data to start fresh again, and we change the current and max value to 3. I'll go ahead and add pushback again. We go into play mode, and the hearts should decrease in value every time the player gets hurt. Okay, we'll set up coins now. We change max value to 100 and delete any saved data. We go into pick up items. I won't go over this class in this tutorial, but it's needed to pick up coins. Every time the player picks up a coin, we will increment the world float by 1. We create a coin HUD to display the value amount. We add a world float HUD, and this time I'm going to create another inspector tab to make sure we set the correct world float. We set the type to numbers, and set the text mesh Perl reference. I duplicate some coins in the scene to have something to pick up. We go into play mode and we see the coin count increase. And quickly, I'll create the continuous type of the world HUD. We set the image type to filled and fill method to horizontal. It's not the prettiest looking health bar, so it will be up to you guys to choose a style of the UI and make this stuff look pretty. Finally, I add the HUD and set its type to continuous, and set the reference to the player's health. We set a max value of 3 and set the reference to the image. We refresh the saved data and go into play mode. Okay, it worked. The HUD is one of those game objects you'll probably create a prefab for. However, you'll see that if we create the prefab, the reference to the world variable will break. There it is, no more reference. And that's because health and other world variables exist in the scene. In order to get a solid reference, you can create a scriptable object that references these world variables. Scriptable objects exist in the project and not in the scene, so they're great for creating prefabs with. Okay, we get rid of the prefab and go into the player. We enable isScriptableObject and create the scriptable object. We make sure the correct reference is set. Now, we reconfigure the HUD and make sure we are referencing WorldFlood as O, the scriptable object. Now we create the prefab, and we see that the reference survived. Before we move on, let's deal with player death. We go into the player health component and look at the unit event onMinValue, which means the player has reached its lowest value and has died. This event can call a level reset from the world manager, or it can reset the scene. We'll reset the level and increase the player health back to 3. We'll go into play mode and see how that works. Since there is no checkpoint reset, the player will stay at the same location and it will look like nothing has happened, but its health will have increased. But before we go into play mode, I did find a small little bug which can be fixed easily for now. Open World Manager script and go to line 151 and comment out recovery.clear. Save and compile. Doing this will allow the player to process the recovery period correctly during a reset. Okay, now we clear the save data and go into play mode. The player has officially died and reset instantly. Let's make this a little better. You don't have to follow along with this part since I am using a sprite for the player I created today, so it's not in the project. We're going to add a finite state machine and create the death state for the player. We add 3 states. The first is called wait and it does nothing. The killed state will make use of the onEvent node, and the reset state will call the world manager. We set the player's death signal through Sprite Engine, since the signals in the AI finite state machine and the player aren't actually connected. We block input so the user can't move the player in this state. We disable the player's box collider so it doesn't interact with the enemies, and we run this state for a few seconds, then jump to the reset state. We use the onEvent node again. We re-enable the player's collider and call reset all. Now, in the health component, instead of calling world manager, we call the AI finite state machine and set it to the killed state. We go into play mode, and I do want to say that I'm always looking to generalize common use cases, so for the next update I will include a player death node so we don't have to create several states for it. And there you go, the player death state. During this event you can also call it a game transition, but I need to change AI finite state machine so it can run while the game is paused, because right now, game transitions will pause the game. This is an easy change and it will be made for the next update. Oh, and there's one thing I forgot to do, and that is to set AI type to no collision checks. Okay, let's move on to the checkpoint system. The checkpoint system is pretty straightforward. As soon as a player walks into a checkpoint trigger, the system will reset to that location during scene start or a game reset. We create an empty game object. We add the checkpoints component and give it a unique name for saving. We set the type to priority, which means checkpoints with a greater index will override checkpoints with a lower index. And the checkpoint will save automatically as soon as the player enters the trigger. We create our first checkpoint and set its index to 0. We set its position in the scene. We create a second one and set its index to 1. We go into play mode. We go into checkpoint 1 and we use the functionality of demo 2 and simulate a game reset. The player is reset to checkpoint 1. We go into checkpoint 2, and since its index is greater than the previous checkpoint, this will become the new checkpoint. Okay, great. We go back to checkpoint 1, and on a game reset, we see that we still reset to checkpoint 2. Now, we set the type to any. We go into play mode, and we notice the player gets reset to checkpoint 2. Now we go to checkpoint 1, and since the type of the checkpoint system is now set to any, the new checkpoint will get reset to checkpoint 1. Okay, great. Finally, we're going to implement a simple level unlock system. This will be very basic. I'm simply going to show the structure with the tools we've already learned so far. And of course, it will be up to you guys to make this look good. Okay, here we go. First, we're going to duplicate the current scene. Before this, we name it level 1, and the second scene will be level 2. Now we create a third scene. This will be our level selection menu. Make sure to double click into them or you might find yourself modifying the current scene. We go into the build settings and insert tutorial 1 and tutorial 2 so we can load them. In level select, we disable everything but the camera and world manager. We create 2 UI buttons to jump into the scenes. As you can imagine, you can obviously extend this to include all the levels in your game and include some really nice UI here. We add manage scenes, leave the default settings, and include a load scene transition. Level 1 should always be unlocked, so level 1 button can always connect directly to manage scenes and load level 1. And we need to include the event system for the UI to work. We jump into play mode and go into level 1 and see that everything worked. Level 2 is where things get interesting. Here, we have to check if level 2 is unlocked. We will use a world float for this and treat it as a boolean. We name it and set its initial value to 0, which means false. Next, we configure an AEI finite state machine to check if we can move into level 2. We create 3 states. We will use a world float logic node to check the state of the world float. If it's true, we go into the open state. We use an on event to call manage scene and load level 2. For the UI button, on click we check the AI. We set the AI type to no collision checks and jump into play mode. And of course, we can't go into level 2 because its value is still false. We save and go to level 1. We have to find a way to unlock level 2, so we create a condition for the player. Once it's met, we unlock level 2. To keep it simple, we create a territory, and once the player is inside it, we unlock level 2. We first create a world float, and name it the exact same name. We initialize to 0 and enable the save option. Once the player is inside the territory, we jump to the unlock state. We use the on events and set the world float to true. Okay, because the checkpoint system, we were teleported inside the territory, we can now see that the world float value is now 1, which represents true. Level 2 is now unlocked. We go back to level select. We enable save option. If the save option is not enabled, it will not initialize to the correct value. We see that the value went to 1, so now we should be able to go into level 2 this time. Okay, everything worked. We are in level 2 now. Okay guys, that's it for this tutorial. The system also saves the inventory by default, but we'll leave the inventory for another day. And I know there are more general use cases for saving game state, So if you have any questions, please let me know. I'm always looking to generalize the system to make it easier to use. Thanks for watching and see you in the next one.